All right, welcome everyone. Today is October 12th, Monday, and we are going to be looking at our final section of notes today called rational numbers. So if you're watching this video, you should be done with your unit test. So you should now be 89% finished with Edgenuity. So you are now ready to go on and complete your last section so that you can wrap up everything for the 9 weeks. So this is the last week in the 9 weeks, and you just have this one section, rational numbers, remaining. Perfect. Excellent. So let's talk about what rational numbers are. So the first thing we need to know is rational numbers are all three of these things. They are all integers, all fractions, and most decimals, and we'll talk about most. So all integers, examples of those would be the ones that we've been talking about. So like -1, that's an integer. +5, that's an integer. -30, that's an integer. So any counting number, positive or negative, that counts as rational because it's an integer. Good. The next thing is all fractions. So all fractions are rational numbers. So you could have positive fractions, like 1/2. You could have negative fractions, like, say, -5/12. And you could have improper fractions. You could have 25/3. That would be rational number. So any fraction, no matter what it looks like, even it could be a mixed number. So a mixed number is a fraction as well. So 1 and 2/5. That would work. That's rational. So any fraction, no matter what it looks like, mixed number, any fraction, positive or negative, is a rational number. Good. And then next we have most decimals. So make sure you know that it's not all decimals, it's most decimals. So what we mean by most decimals is the only kind of decimals that count as rational numbers are these ones called terminating. Terminating. So terminating decimals, these are decimals that come to an end. So the terminator was the person who got rid of the aliens. So terminating means that they ended decimals. So if they terminate, an example there would be like this. So if I have 0.5 or 0 and 5/10, that decimal ends. It ends right here. There's nothing after the 5. Another example would be like this, -3 and 48/100. This decimal ends right here. There's nothing past that. And so any decimal that comes to an end is terminating, and that counts as rational. So the only scenario that you would have something that is not rational, the only way you have something not rational is you have decimals that don't end. So if they do end, they're rational. But if they don't end, we call these repeating decimals. And so repeating decimals are not rational. They repeat forever. So an example of that is you may have seen in your calculator sometimes that you'll get this, where it's 0.3333, and it'll just keep going. And then eventually your calculator will stop because it'll run out of room, but these threes will really go on forever. So this is a repeating decimal, and that is not rational. The next one now, after that, is we have something like this, where we have a little bar. And you may have seen this bar before, but maybe not. So this little bar right here, that's called bar notation. And what that means is whatever the bar is over, that number repeats forever. And so instead of, this is not just 5/10. So this and this are not the same. What this one in red means is this means 0.5555 repeating forever and ever. And so we could do this for the one above. So 0.3 bar notation is the same as this. So if you ever see this little bar, that means it is not rational. It continues on forever, and it is not going to be rational. And then you could have a bar that's over just one part of the decimal. So if you had something like this where it was 1, 2, that would mean that the 1, there's no bar over it, so it doesn't repeat. but the 2 does. So it's 0.1222222. And so it doesn't matter what the numbers are, but if it goes on forever, it is repeating. Excellent. Okay, so the next thing we need to do is we need to graph fractions and decimals on a number line. So we're going to be talking more about fractions and decimals because they are rational. And so here we're going to try and locate things on a number line. And so the first thing I'm going to look at is my proper fractions. And so you'll remember from elementary that proper fractions are fractions that have where the smaller number is on top, or is the numerator. So the most common example that you should probably memorize of a proper fraction is 1/2. And so 1/2 is proper because the numerator, 1, is smaller than the denominator. And so when I look at 1/2, I say, okay, this is like I cut a pizza into 2 pieces, but then I only get one of them. And so I know that 1/2 is right in the middle of 0 and 1. So right here on the number line, right in the middle, is 1/2. So if I get 1/2 pizza, that means that I got right in between 0 and 1 whole pizza. Good. And then another really common example that you should have memorized is 1/4. And so now instead of cutting my pizza into 2 slices like I did before, now I'm cutting it into 4 slices. And so if you have 1 piece of pizza out of 4, well, now your slices are getting a little bit smaller. And so now 1/4 is right here, halfway between 1/2 and 0. So right there is where positive 1/4 would be. So 1/4 is like if I broke this up into 4 pieces, this would be 1/4, 2/4, 3/4, and then 4/4 is the whole pizza. So any proper fraction is always going to fall right in here. So you could imagine if I cut a pizza into 100 slices now, if I gave you 99 of those, that's as much as I could give you without it being improper. So the only number that's smaller than 100 is 99. So this is still a proper fraction. So if I gave you 99 pieces out of 100, that would go right here, right super close to 1. So you don't quite have 1 whole pizza, you've got 1 tiny little slice left. But no matter what, every proper fraction is going to fall between 1 whole pizza and negative 1 whole pizza. Because if it was more than 1 whole pizza, it wouldn't be a fraction that's proper anymore. And so I could locate ones that are negative proper fractions as well, but I know that if it is proper, if the top number is smaller, it will always be between 1 and negative 1. So an example over here on the negative side would be like negative 3/8. So let's think about that one. So for negative 3/8, I've cut a pizza into 8 slices, and I've only gotten 3 of them. So I think of, okay, well, where would half be? Well, half would be if I had 4. If I gave you 4 slices out of 8, that would be half right here, negative 1/2. But since I only gave you 3 out of 8, it's going to be a little bit closer to 0, like this. So I'm thinking right about there. So it's not halfway, it's a little bit less than that. So negative 3/8 would go right here on the number line. Excellent. Good. And then improper fractions are able to go on the number line as well. It's just that improper fractions, you're either getting more than 1 whole or you're getting less than negative 1. And so an example on the positive side here would be like if I have 14/4. And so this is improper because the larger number is on top, and so we need to think of this like division. So remember, fractions are just division. So 14/4, that's just 14 divided by 4. And so you could do that by hand if you'd like. You could do it in a calculator if you'd like. Calculators are available to you. So I'll take the shortcut here and just type it in a calculator. 14 divided by 4 gives me 3.5, or 3 5/10. So that's what that really is equal to. And so now that I know what the decimal is, I can say, okay, well, this improper fraction is where 3.5 is. And so I know that 3.5, 3.5, goes right here, right in the middle between 3 and 4. So this would be 3, this is 4, so right in the middle here is where 14/4 goes, because I know it's the same as 3.5. So every fraction has a decimal. Perfect. And then I could do one on the negative side just for another example. If I do negative 12/5, again, I'm not going to just jump right in and say, well, let's go to -12 or let's go to +5. I need to do this division to see what I get. And so I'm going to do -12 divided by 5 in my calculator. And I'm going to get that the answer there is 5 goes into 12 twice. And there's going to be a little bit left over. So the answer is 2.4. And it's negative. So this is -2.4. And so now I can see where it goes on the number line. Here's -2, here's -3. Right in the middle is -2.5. So -2.5 is right here, and -2.4 would be just a little bit closer to -2. And so that's where that would go. So that's going to be really important. Always use 1/2 as your guide. So always go to -2.5 and then go from there. That is your North Star, if you will. So lastly is how to go back and forth between fractions and decimals. So some people are like, Mr. Kerr, I really don't like fractions as much, and that's okay. I get that. And what we can do is if we use the fact that fractions are just division, we can convert any fraction into a decimal. And so just like you saw up here, -12/5 is the same as -2.4, and 14/4 is the same as 3.5. Any fraction can be made into a decimal by just dividing. And so here, this would just be 5 divided by 100. Now, if you learned how to say these correctly, there's actually a bit of a shortcut. So instead of doing the division, if I say this as 5/100ths, that fraction there, you might remember that whenever you have a decimal, so 0 point something, whenever you have it, this first one is called the tenths, and the second one is called the hundredths. So if this is 5/100ths, I know that the answer for the decimal is 5/100ths. So 0.05. So this is 5/100ths, and this is also 5/100ths. So if you learned how to say it like that, that's actually an advantage where you didn't even need to do the division. You didn't need to type 5 divided by 100. You just knew it right away. For the second one, you could do 10 divided by 50. That would work to get you the decimal here. Or if you wanted to, you could go to hundredths as well. So for this one, if we're saying, well, if I make it into hundredths, then I know that my answer is going to be 0. Whatever hundredths. And so I say to myself, well, what could I do to 50 to make it 100? I say, well, I could multiply by 2. And so if you multiply 50 times 2 to get 100, that would work. And so whatever you do to the bottom, remember the rule is whatever you do to the bottom, you have to do the top as well. And so you can't just magically change one number, but if you change both the top and the bottom, it's okay. So 10 times 2 is 20. So 10 50ths is the same as 20 hundredths. And again, you could just divide. Either of these would get you the same answer, but if this is 20 hundredths, I know the answer over here is 20 hundredths. Good. And then for the last example, this one, it doesn't look like it's going to go into hundredths very easily, so you can just type it in. Fractions are just division, so do 3 divided by 8. And so I won't waste your time. I'm going to grab my calculator and do the same thing. 3 divided by 8. And I just look at what my calculator says. So my calculator says this is 0.375. And that's the correct answer. All you need to do is read it from top to bottom. 3 divided by 8. 10 divided by 50. 5 divided by 100. And any of those things that you type in a calculator will get you the correct decimal. Okay, so good luck with that. I hope that this helps a little bit to convert fractions to decimals, and then that way you might be able to see how big or small they are on a number line.